So in today's lesson, what we're going to do is take some natural nuclear decays and their equations, and we're going to figure out what the missing pieces are. So I was kind of giving you an introduction to this on the first lesson, where basically, this type of element is going to be radioactive. It's going to give off a particle, and we have to figure out what's left over. Or in some cases, we have to figure out what particle was lost. And so what I've done, just so you know what we're going to do here, is I've crossed out artificial transmutation questions because we haven't covered that yet. And then what we'll do is we'll cover that and revisit this. But I've gotten rid of them. So this first worksheet, I'm going to work through the whole one. I'm going to upload it so you can follow along and have something to write on, or you can just write on a blank piece of paper. But from this, you are going to get an idea of how I think about filling in these equations. Then I'm going to upload a second worksheet, which is much shorter. There's about 9 questions on it for you to complete on your own, and then you'll upload that. Okay, so let me get into it. This first question starts out with potassium. It has an atomic number of 19. It has a mass number of 42. And through decay, through transmutation, through radioactivity, it decomposes and it changes. The skill that I kind of gave you an introduction to was that I still like to do what we've been doing all year. I put a line down the arrow. It separates the reactants and the products. Everything needs to be balanced, so it just helps me visualize. So when I look at this, I notice that the total amount of mass is 42 on the left side of the equation. On the right side of the equation, I have a 0. And so if this particle had a 0 mass, and I started with a mass of 42, I need to end with a mass of 42. So whatever this particle is going to have a mass of 42. I have gone through some form of decay, which let's do this part now. What type of decay does this particle belong to? There is no reason to memorize this when it comes to the Regents exam. But on table O, we have a -1 E0. So this particle and this particle are the same. So we must be looking at a beta particle. And we must be looking at this beta emission, meaning a beta particle was emitted. So now I know what the particle is. Remember, I told you don't need to know what it really means, but I do know that the bottom number is -1. The number of protons right now on the right side is -1. If I started with 19 protons, 19 bottom number, the right side of the equation has to have a total of 19. And if I have -1, you're basically doing some simple algebra where -1 plus what number equals, I'll write it on this side, equals 19. 19, let that focus, 19 equals -1 plus what? And the answer is 20. And so now I know the proton count, I know the mass number of this new element. So what do? You find your reference table, you find the atomic number 20, which is calcium, Ca, and now you have determined and you have completed your first official nuclear transmutation equation. So let's keep going. This is an element with 94 protons and 293 proton plus neutrons. So when I look at it, I started with 293. The 239. The two particles combined have to have 239 of a mass. So 235 plus 4 equals 239. My new particle has a mass of 235. 94 was the total number of protons I had. So if my new particle has 2, how many are left over to still keep that 94? 92. Go to my reference table. Atomic number 92 is uranium. So this new particle is uranium. And the type of decay is based off of what particle was emitted. And that's alpha. Just to show you so that you know where it came from instead of just your mind or your notes. Alpha particle right here. I'll keep going. So now we're going to figure out what the particle is. So in order to do that, it gets a little trickier, but it's really not too difficult. Right? So this uranium with 92 protons has broken into some particle and thorium. Thorium has 90 protons. So if I started with 92 on the left and I have 90 on the right, this particle has to have 2 protons. I started with 235 mass. I ended with 231 mass. This particle must have a mass of 4 because 4 plus 231 is 235. So what particle has a mass of 4 and a proton count of 2? Well, that's an alpha particle again. Okay, now I'll go here. So I'm looking at, and this is actually, I'm sorry. This is not one that we're going to do because this is an artificial transmutation, and we're not working on those right now. So we're also not going to do number 4. So now we're looking at number 5. Now, number 5 looks very similar to number 1, but it's very different. It's very different. The mass is different. So the mass is 37. The protons is 19. I now have a mass of 0 in my new particle, which means I'm still going to have a mass of 37 in my other particle. My proton count is 19, started as 19, and now it's only 1, plus 1, plus 1. So if the particle that is given off is a plus 1, then how many protons do we have in our other particle? 18. And that's because 1 plus 18 is 19. Let me write this down and I'll add one more thing before we do the last problem. So again, you go to your reference table, you say what has an atomic number of 18? 18 is by AR, argon. And so now I have that. So the one thing I want to point out that a lot of people get confused on or they have trouble with is the -1 + 1 thing. So I'm just trying to keep you cognizant of just do the math. All right. If this is -1, that means whatever number I put here is going to be 1 larger than what I started with. And down here, if it's +1, that means this is basically saying, let me backtrack. This is basically saying that there's an extra proton at the end. +1 is saying one of the protons came out. And when we go to look at what particle that belongs to, we're going to find that 0 + 1e is represented by a positron. And so this is a positron emission. All right. If you take these steps and you just carefully do the math, you'll be okay. All right. Last one. PO 84 and 218. I have my particle, so I know that this is going to be alpha. Okay, so what is left over? Well, the alpha particle has 2 protons. So if the alpha particle has 2 protons, and I started with 84, 2 of these protons left. How many are left over? 82. Okay, if the alpha particle has a mass of 4, and I started with 218, So 218 lost 4 mass. 218 is now going to become 214. What is the element with an atomic number of 82? Right here, Pb, lead. All right, cool. So what I'm going to do is I'm going to upload this other sheet for you to work on. This other sheet is just as simple. Nothing crazy, nothing difficult. You need table O. You need your periodic table for your atomic numbers. So what I want you to make sure you do in here is identify X in the first set, which basically is saying this is a blank. Okay, what is the blank? I'm going to ask you to go backwards for the first one. Try and figure out what it started as in order for you to figure out, well, from what was created, what did you start with? And down here, I want you to identify these equations as either alpha, beta minus, or beta plus. All right. I guess I'll give you a little heads up that this is artificial and this is artificial. But I want you to challenge yourself and see if you can figure it out. That's all I'm going to say. All right. I know you don't know how to do 5 and 6 just yet, and 7, but you definitely can figure it out. And if you don't try to figure it out, what good is it? Right. So give yourself a little bit of a challenge and go for that. And I'll kind of give you a rundown on what to do on the next lesson.